So we're going to start off with a little bit of review of some stuff that should be familiar from Algebra 2. Also, check the website for the stuff on graphing by hand without a calculator, because that was a skill most of us needed to brush up on. I'm going to run through the vocab real quick. We'll do an example. I don't have to do too much of an example of the extrema and zeros, but then we do need to talk about end behavior. So just remember what all of these words mean. Zeros could also be solutions and roots. Extrema will be maximum and minimum. Local extrema are just the ones that are higher and lower than the values around them. The maximum and minimum for the function might be called the global maximum or minimum, or the local or the absolute maximum minimum, to contrast with local extrema. And then end behavior we're going to cover. So just to point out a couple of things visually, here we have our extrema, here, also called turning points. We have our roots, or our solutions, or our zeros. We have one here, here, here. The ones that bounce off the graph are called double roots, where they have a multiplicity. We could have multiplicity greater than 2. And end behavior is what's happening as x moves this way, what's the graph doing? As x moves this way, what's the graph doing? Alright, so to find the extrema and zeros of the following polynomial, for that one, for these questions, what you're really going to do is plot this in your y equals on your graphing calculator. And you're going to find the extrema, you're going to do the calculate max and min. So that's calculate, second, calc, max and min. And to find the zeros, that's calculate zeros. Let me know if you need me to run you through that. I think most of us knew how to do that. If you forget how to use your graphing calculator to work through that, let me know. Visually, we'll find our extrema here and here. So we would find that this one would be approximately, like 0.6 and 5.1 would be really, so it would be like negative 0.6 and like 5.1. And then this other one would be like positive 0.6 and negative 1.1. That's just my best guess. The zeros are happening at x equals, let me switch colors here. X equals like 2.25, and so that was negative 0.25 and like 0.8. Those are estimates. We'll skip that. End behavior. There were some, not shortcuts, but kind of a pattern to remember. For odd, they'll be opposite of each other. For even, both sides will be the same. When we have a positive leading coefficient, we're going to end the way the leading coefficient is. So if it's positive, we're both going to end right. But for even, they're both the same. For odd, they're opposite. When a is negative, we're going to end down. And for even, they're both the same. For odd, they're opposite. But that's not the notation we use. The notation we use is called limit notation, where from right now, all you need to know is how to set it up to show the end behavior. X approaching positive infinity, that's to the right. And x approaching negative infinity, that's to the left. So the end behavior for this one, we have a negative a, and it's odd. So that's down to the right, up to the left. So let me just write those out real quick. So these are read. The limit as f of x approaches, the limit of f of x as x approaches negative infinity is positive infinity. The limit as f of x approaches positive infinity, the limit of f of x as x approaches positive infinity is negative infinity. And I will let you try that one on your own, and we'll do that one as a quiz question. After you finish the quiz question, make sure you go and look at the resources for graphing by hand without a calculator.